Hey everyone, welcome back again to another exciting installment of the AP Calculus AB exam review session. If you have joined us for the first two, sincerely I welcome you back. If you are brand new to the video today, definitely don't forget to check out our previous videos. I ran both of them earlier. I've been trying to keep an active eye on comments that people have been posting and asking questions. I try to absolutely respond to everything or provide responses as best as I possibly could, given the information that's available to me. Definitely today it's live interactive. Feel free to fire off any questions at all. As I said in the last video, if you got to check it out, I'm going to try to fit as much in as possible. The goal ultimately was to make it no matter what through your first semester, basically the fall semester, because that would take you all the way through differential calculus, which you've been completely responsible for covering and reviewing and knowing since you got kind of told to stay out of school, which quote unquote normally would be the best information ever. Now you kind of just have to go your own way with the review. I know teachers have been in contact with you about setting things up. More than likely, if you're here, this is not your only AP exam. And for real, you all should just be truly commended for your dedication to this in preparation. You're going in uncharted waters, and all we can ever do is try to provide and help however we're able to. So I'm not going to spend too much time on open sides again, because these are already there. Like, nothing new here. That's me. Yay. Don't mind me looking too happy with my SAT test booklet. Again, the units that I'll be covering, this is all again available directly to you on College Board. The only real big changes that we have to discuss, not that. I've included a couple things on this slide right here. Basically, this is going to be a YouTube video for an ad that College Board put together for what all to expect for the actual test day and what to keep in mind. It starts out with what to expect your 2 days before, which again is going to be your AP ID that you're going to have to know, and then you're going to have to include like your first initial last name for anything that you're submitting work-wise. Also, I've included a link for the test, the keyboarding tip sheet with the whole test day checklist. You're going to see a link here. It's all, actually, before I leave to point that out, it's all going to be located at this website right away. Jot down, take a picture of it with your phone, something. Don't forget to check this out. It's got you set up with 5 key steps that you have to make sure that you are completely aware of and prepared for going into the actual test structure. Like, this is going to be the exam day checklist. Again, the goal is to kind of create one of these for every single AP test that you're taking, no matter what. It's just about giving you some comfort and structure in knowing what to expect. Definitely trust me, it's way easier to tackle something different when you can at least pre-prepare or like prepare yourself beforehand. Pre-prepare? That'll work. Then I do have like the keyboarding tip sheet, a little screenshot here. I know it's totally ridiculously small on the side. I just wanted to show you what it looks like so that when you do go to take a look at all these docs, you have kind of a visual idea of what should be there for you. And as far as your notes, we know that since these are open book, open note tests, you definitely want to have some structure to the madness. Like, I know I would break it into 3 core categories: the limit properties, the differential properties, and then the integral properties. Here, I just have like a little screenshot of what my notes would look like for the limit properties, at least. Basically, just hit the heavy hitting concepts right away. It's just so I don't have to like kind of force memorize. If there's something that's been tripping you up, definitely make a note of it on these notes. Or if you're simply using your notebook from class, do what I would do. Grab a Post-it or like a stack of Post-its and just kind of make them like little dividers out on the right-hand side margins with exactly what key topics are located around the notebook. Preparing for some structure to the method of the madness that we're dealing with, it's half the battle for real. Anything that you can put together, any way that you can set yourself up for success, don't forget. Because, well, we're going to jump right in. One of the foundational concepts of differential calculus is when we start putting the real world ideologies into the mix, going with motion specifically. The probably biggest topic that presents ultimately like kind of a straightforward challenge right away: related rates. They're never impossible, for real. We just have to remember how to react. Actually, with the whole related rates, All we ever have to make sure about is just remembering that there's a method to the madness when it comes down to it. With the whole related rates, you definitely want to get out of your head as much as you possibly are able to. With the whole related rates, it's just about making sure that you don't assume anything. Really try to pay attention to the units. Like, for example, in this question, well, a circular pool of water is expanding at the rate of 16 pi inches squared per second. At what rate is the radius expanding when the radius is 4 inches? Does Prince Review have any review sheets by chance? Well, we actually, in the Cracking the AP books, that definitely is going to be our most up to date and helpful approaches for tackling any of the AP tests. We offer them for an overwhelming variety of the subject matter. Anything that we don't have like a really just complete one-step sheet, it's going to be basically just going through the chapters, looking for the little bubbles that we have are going to be the high points. But now fully be aware, kind of don't want to just do kind of a copy and paste thing. It's not that it's like not going to help you. No, it totally will. Just if you're the one that's going to like kind of author the document for your help, it's only going to be a benefit to you that way because you're going to understand exactly how to read the document, how to interact with the document. Again, it's definitely going to be the most beneficial thing to use directly the notes that you got in class. With the whole AP structured regimen, with your math teachers and the textbooks they use, everything they've given to you, it's been designed to set you up for success for the approved AP course content. Believe it or not, the hardest questions have already been completed. Everything that's in your textbook that you've done throughout the year, definitely significantly more difficult than what's going to be on the test. But now, so I do hope that helps. With the whole related rates ideology, the whole thing to keep in mind, it's a change with respect to time. This is definitely going to be piggybacking off one of the last concepts we discussed at the end of the last video. We're at the part in calculus where, for the most part, we're going to be taking a derivative set equal to 0. Here, we just have to be careful. Now, a couple things to keep an eye out for. You can use, well, you're going to have to like set up a formula or some equation to relate the information. My little secret, I've kind of always just focused on the units in a question. It's like if something is squared with times particle motion on the test here, I think it's needed 8, I'm not sure. Well, so with the particle motion, that would qualify as potential differential topics because you know you're dealing with position, acceleration, velocity. And so here, I'm gonna like put the slides up just to verify. Depending again when your teacher would have done it, that's gonna be something that possibly was not shown to you. But here with this, we'll definitely discuss the relationship between the position, velocity, acceleration. If anything, for most up-to-date FAQs, College Board, the AP coronavirus update would be this friendly one. Are the rate in, rate out functions in the test too? I've heard different things on this. For this, again, I'm not with College Board, like very much not with College Board. But all I can ever do is offer conjecture. That actually did get asked to us or to me in the last video in the comments section. The only thing I can definitely say is that you're required to know and be able to be like set up for it. I did just want to walk through like a handful of questions as many as possible today to kind of just bring it back into the focus. With this, though, I can't definitively say one way or the other, like, oh, this will be on it, this will not be on it. I really wish I knew for real, or like that I could just kind of predict the entire test. That'd be insane. Imagine the power. But here, I can only offer like what we can, at least to kind of bring back the earlier stuff into mind. I do hope that helps, and I really do wish I had more of a definitive answer to that. I have no way to know, unfortunately. I'm sorry. But now here with the related rates, like it's usually either between related rates and optimization. If I had to guess which of those two would show up, I would definitely say the related rates, only because there's so many more little things to keep track of. And it's a great way to kind of test the concept of how you're identifying what you know and what you don't know. But as I say, I always try to look for the units. Since I have like inches squared per time, well, anything squared, that's always area, no matter what, especially calculus. Like think about like an area of a rectangle. If it's 3 feet by 2 feet, that's 6 feet squared for length times width. And so when you have your squared term, think area. Since I think area, and I'm dealing with a circular pool of water, well, Area formula for a circle to the rescue. Notice all I'm doing is getting out of my head now, potentially just trying to extract whatever I possibly can. These questions have a really interesting way of making you kind of feel completely unprepared or just make you question life in general. Just take it one step at a time. Remember to breathe. You will remember. Just have to keep cool. And so with the whole pool is expanding, well, notice it's saying the inches squared per second. If it were just the actual area, like a value for A, well, here, this is denoting a change, which means I know the change in area with respect to time. And so with that, and sorry, my stylus goes here, should be inches squared per second, just like it says in the question. But now with this, I have to figure out at what rate is the radius expanding. Okay, so they're telling me to find the rate of that. That's my unknown, which means change in radius with respect to time. That's my finish line. When the radius is exactly 4 inches, okay, I am now completely set up for success here. I have my instantaneous value to plug in. One of the biggest mistakes that people make immediately is plugging in too early. On a question like this, you don't just plug in the 4. We haven't done anything calculus related if we just do that. The only thing with calculus and regard, we're totally going to be utilizing the chain rule technically because we have to integrate with respect to time. Derive the left side, the dA over dt. The pi is just a constant, so I mean, it'll be there, just hold off on it for right now. We're going to use the power rule in conjunction with the chain rule for the r squared derivative. We know we take the exponent out front, subtract 1 from the exponent, so just r to the first, and then dr dt. Immediately, if you get to this step, what equations are we expected to know? Like, do we have to know the volume surface area equations? Which ones do they give us, expect us to know? Again, Perla, anything that has shown up in a textbook is completely fair play. With this, sometimes they can provide a formula in a question. Other times they definitely don't have to. So with like this related rates example, I'm totally responsible for knowing area of a circle. I just have to know that. We've had exposure to that since geometry. Definitely, possibly even earlier than that. But when we have these formulas, if it's something that's truly completely like random or just completely unknown, they could, again, provide it for you, especially if it's not like one of the common formulas. But in calculus textbooks, you know how in the front cover, they have a lot of the differentiation formulas and then any other potential geometric formulas. If you take a look in your related rates chapter section, they'll also provide in your textbook usually the most common things that we'd have to be able to recall for these types of questions. Again, I wish I did know more of a definitive answer. I'm not with College Board, so I don't have an exact 100% definition or answer to what we would be required to know. Now, notice I'm just gonna like take a quick pause to check that I have everything accounted for. A dA dt, I've got that right here. 2 pi r, I know my instantaneous radius, which means dr dt. I've done right. I've done good here, so to say. I'm just now going to plug and play, take it to the bitter end. And so 16 pi inches squared per second. And you may be thinking, do I really have to include the units here? Technically, you should. It's definitely like accepted. If anything, if you have trouble identifying the units that your final answer should include, it can definitely be a benefit for you to like utilize them and treat them as kind of rational expressions so that you can see what all cancels. But now I have to isolate the drdt. So if you think about it, this is going to confirm my final units no matter what. I know I've got inches times inches divided by seconds on the left. I'm going to divide over an inch unit, which means it's going to cancel down to inches per second. Whenever you're dealing with like the differential of this drdt, you're usually only going to have the top unit to the first power, the bottom unit to the first power. If you have other than that going on, you made a mistake. Just kind of have to be careful with how you're setting it up. And so with that being said, I know my final units. I'm going to jot them down here. Now I'm going to go unitless just because it'll make it easier for writing, quite honestly. I'm totally a lazy guy, so less is more. No, I'm just kidding. Divide the a pi over. And then game, set, match. You totally could leave it as 16 pi over a pi. It's absolutely mathematically solid. Here, we just know that the radius is going to be expanding in 2 inches per second as our final answer. The trickiest part with the free response questions, providing the verification, providing your justification for your reasoning. When they do have only or whenever you're in a question and the only thing left to do is simplify the arithmetic, don't waste precious time trying to get the most reduced fraction or anything like that necessarily, only because this is exactly equal to 2 pi, or to 2. There's no possible way they can mark you incorrect. 16 pi divided by 8 pi is exactly 2. Whenever you don't have to reduce, then definitely take that time elsewhere, to a different part of the question. Here, you can only do that when the simplification is the final step. Let's take a look at another one. Probably the most common related rates question ever in life to keep you focused. A 25-foot long ladder is leaning against the wall and sliding toward the floor. Yes, the falling ladder. If the foot of the ladder is sliding away from the base of the wall at a rate of 15 feet per second, okay, how fast is the top of the ladder sliding down the wall when the top of the ladder is 7 feet from the ground? Yay. Honestly, if you're not sure about the formula just yet, draw a picture. I know I've got a 25-foot long ladder. Then it's sliding down the wall. So here's your wall. And the bottom of the ladder is going further out. Oh, snap. Probably the first theorem you ever learn in life. You kind of never forget it. It's just a beautiful theorem. It's all alphabetical. You're squaring everything. Anytime you have a right triangle, this is the theorem that gets you out of the jam. Pythagorean. I'm just going to make a note of it here for right now. That's going to be my Pythagorean theorem. And sorry, it should be an exponent of 2, not the z to the z power. So now here, I just have to be careful again, identifying what it is that I know. I know the vertical is going to be the y, and it's sliding down. The base is sliding outward, so that's going to be my x, my horizontal displacement. The number of the ladder is never changing. But now here, remember how I said a lot of times people get plugging in way too early in related rates. That, believe it or not, is the most common situation that happens. Here, well, to really truly know what I'm going to have to plug in, I have 3 different variables in that Pythagorean theorem. I have to know instantaneous values to plug in for each. You'll notice the ladder's never going to change. I do know the instantaneous, though, is 7 feet from the ground. So if that's my vertical, my hypotenuse, you may already know this Pythagorean triple, quite honestly. I kind of think of them as locker combinations. The friendliest ones, the 3, 4, 5, double everything in that. The 6, 8, 10, the weird one, if your parents ever get mail, it's usually a longer envelope with a shorter height. That's going to be the kind of weird one, the 5, 12, 13. Believe it or not, this was another Pythagorean triple. If your height is 7, your hypotenuse is 25, your base can only be 24. And yeah, the 7, 24, 25. If anything, I extract that just because I know it. You totally can plug those 2 values into your Pythagorean theorem, carefully set up your arithmetic, and you'll be able to identify the instantaneous for x. So that's perfect. I just now have to identify what else I'm going to need. So the foot of the ladder is sliding away from the base at a rate of 15 feet per second. Again, let the units help you. I have feet to the first power divided by seconds to the first power. That's just a differential. And so it's dealing with the base sliding out. I know I've got the dx dt. Only because, again, that's my horizontal displacement. And I have to find, according to the question, the top of the ladder sliding down. Because now that I've labeled everything that I know, I'm just going to go and plug and play into the expression that I need. Again, Pythagorean theorem to the rescue. However, the ladder's never going to change. It's constant. I got to get that in there right away. If I take the derivative, so 2x dx dt respect to time plus 2y dy dt respect to time equals, yay. Just have to be very careful. Derivative constant, always 0, no matter what. Now I just have to plug and play, verifying, of course, that I have everything I need. My x value, check. My dx dt, check. My y value, yay. My finish line, I did good. It's simply just about getting out of your heads. Don't ever keep anything up here. If you're like me, it is a hot mess up here. Emphasis on the hot, of course, but it's just about making sure that you don't do anything in your head. One step of mental calculation at the most. I don't want you making mistakes by combining too many steps at once. Then we just have to plug and play and get the answer. And so that's just kind of be like the issue that we have to deal with when we do plug in the instantaneous values that we already know. You know, like I'm going to know the x and the dx dt. If I subtract it on the other side, it'll become negative. And then I'm going to divide by 2. I'm totally going to be getting a unit, again, of 15, units of feet per second. This one now, so this is going to be negative. It totally makes sense because the top of the ladder is sliding down. The negative definitely verifies the real world distinction of it. But here it's just plugging and playing. I'm not going to take more time here because when you plug it in, you're going to be able to verify the issue or the solution right away. Here it'll be negative 360 over 7 feet per second. Just be very careful. Because then when it comes to these whole related rates, again, they could totally make it one part of it. We just have to make sure that we're clearly labeling what we know when it comes down to it. Be very careful here. With the whole related rates, the formulas, of course, are going to be the critical ones. Again, since it's a completely new format of the test, I honestly don't think they're going to go ridiculously crazy or so far-fetched. I think they're just going to try to combine a lot of concepts within the first question. Then when you finish that with the upload, the second one, it'll have only a couple more concepts, only because you have 15 minutes to do it, and then submit your answer for that 5 minutes. With the whole timing on the test, I know a lot of people are starting to get worried. Oh, please don't be nervous, my friend. I do absolutely understand. One thing, the whole video that College Board released, the link that I put up at the beginning, believe it or not, that can actually provide a lot of comfort for real. It's just going to be a matter of trying to learn as much about it as you can before the actual day. You're completely the worst time of your academic career, for real. Perla, can you primary and secondary equation ever be the same? Can a primary and secondary equation, I think you're talking about a derivative? If that's what you're talking about, yeah, the derivative of e to the x, that's always going to be the same no matter what. Anytime you take derivatives of sine, it's going to be like a kind of pattern of 4, so it'll repeat itself. I think that's what you're asking. I'm not 100% primary, secondary. I think you're just meaning like the first derivative, second derivative. I hope anyway. But yeah, e to the x is an example clearly of where that could hold true. If you have like anything with the power rule, though, that's not going to be true because you're diminishing the exponent every single time. I do hope that helps. So then with the whole ideology of motion on the test, well, we want to be very careful because it's simply going to be about making sure we know what's up with the position, the velocity, and the acceleration. I'll tell you what, it's right there. Most commonly, you're given your position function name denoted by the letter x. Don't forget, though, they can totally name it with like another one, the s of t. That's just how they're starting it out to you. It's one of the clearest indicators of what we're going to have. Now, when you take the first derivative, you're dealing with the velocity. The velocity, you can just write it as v of t, technically, just the first derivative, the x prime of t. Acceleration is your second derivative. That's it, which means it's going to be the second derivative of the position, the x double prime t, or the first derivative of your velocity, v prime of t. With these, the units as well. How do we answer the free request? Okay, so with that one, to answer the free response questions, College Board's giving you 3 different ways to submit the answers. Let me go ahead and put up the YouTube link one more time. This link that will be up on your screen momentarily. This is the one that, for real, check it out as quickly as you can. It's about 4.5 minutes. Probably some of the most informative 4.5 minutes of your life ever. I mean, despite any time you spend with this guy. I did that. Here with the YouTube video, it's going to be College Board directly letting you know, hey, make sure 2 days earlier you get your identification ID for the AP test. Make sure then as well you have 30 minutes available to check in, setting up all your things, completing your test day checklist, knowing the keyboard notes specifically for the calculus. And then it's going to show you like, okay, well, we have 25 minutes for the first question, but they're going to start the timer at 30 minutes. Remember earlier when I was saying in the videos that you're going to have 25 minutes to get your question answered. You're going to notice the timer is going to be down in the bottom left-hand or the bottom part of your screen. It's going to count down. When it gets to the 5 minutes, it's going to completely turn red. That's going to be your cue to start uploading your work or getting everything like set up to go. Ideally, you want to work to finish the question in 25 minutes. Like, do not like plan for 29 minutes at all. You can't risk it, especially with the upload process. But in the video, they do absolutely dissect each of the 3 ways. And in my response to the second video, I address it directly. I wrote in the comments the 3 different ways. Like primary equation being the equation you plug the other value into. Second equation you use to find the value you need to replace in related. I think you're asking, can the original equation be the same as the derivative in related rates? That I've honestly, knock on wood, like I've never seen that happen because like the pi r squared, that one we just had to totally take the derivative, and there's no possible way you're going to take the area derivative and end up with the same thing. Derivative of the area is circumference. And so like I've never seen that happen. I'm really trying to think of an example. Like not a single one is jumping to mind for real. Like I said, the only possibility for that to be the case, the derivative of e to the x is itself e to the x. Like that would be the only thing that I could possibly think about. I do hope that helps. Can I post the College Board YouTube link in the public chat so I can copy it to the YouTube chat? Definitely, if my moderator doesn't mind jumping in to tackle that for me, that'd be fantastic. Here, I'll get it back up. That, or like I said, just take a picture of it with your phone or something, and I can start hopping through additional examples to take a look at. Because this was kind of more than anything toward the end of your discussion for the differential calculus. When you get into your applications of differentiation, you're very quickly approaching the changing point for integrating or integral calculus. When you deal with the indefinite integral, definite integral, then you have like left endpoint rectangles, right endpoint rectangles, midpoint, trapezoidal. And then, of course, you learn the beautiful Leibniz notation and how to go through it. With this, just have to be very careful with when you're going into these concepts. Don't just assume that you know like what your job is. Please make sure you're reading everything possibly that you can in that question that they give to you. You totally have to know your job going into it. And so I hope that the link got made into the, if anything, I'll put it back up again toward the end just in case. But yeah, totally feel free to like take pictures of any of that whatsoever. Because the whole ideology with integral calculus, well, you're completely undoing everything that you did in the first part of your year. Differential calculus takes you one way. You're simply going to study like slope along curves. The integral undoes all of that because, well, Usually have to find area under curves, or you have to find volume. And it's just going to be about understanding the concept here. Probably the trickiest concept beyond a shadow of a doubt has to be the U substitution. For real, that is probably the most guess in check. Thank you so much, Chow. Yeah, the whole U substitution theory with this, you just have to make sure that whatever you're letting U equal to, you're going to be able to find its derivative in there. And we'll definitely take a look at a couple of examples of those. But with this, first of all, we have to know how to find the antiderivative. The biggest thing that many people forget, there's a family of functions that can be an antiderivative. When you're going differentiating, those just have one direction, like you see here. X squared plus 1, the derivative of that is just 2x. No muss, no fuss. We know that. Power rule to the rescue. But if I take the antiderivative of that, that's when it gets kicked up a notch, because you can't just write x squared anymore. Remember, in this, when we take the derivative, the 1 goes away. Derivative of the constant is always going to be 0. How do we account for that? By dealing with all the infinite possibilities of what that antiderivative could be. We have to add the constant of integration. And again, that's where we're going to call it the quote unquote family of functions on the test. Anytime that derivative goes to 0, we do have to account for that in the antiderivative when we apply it. Because now with the whole integral, as I was saying, the ideology came from trying to identify like area of curves. Geometry kept everything nicely compact in straight lines, like a square, a rectangle, triangle. The circle tried to change the ideology, tried to change the game. It totally did. I mean, the only two formulas in the geometry that have like the pies built into them. Like we had to account for that when they were creating these. What the whole antiderivative concept did in calculus is, well, when you have a curve, we had to try to approximate it using what we knew. At that point in time, people just knew like the area of rectangles. So they tried to fit as many of those in there as they could. When you first introduced or were introduced to the concept of the antiderivative, your teacher probably showed you like a progression of things that showed maybe a curve being split up by 2 rectangles. Definitely only accounted for like a little bit of the area under the curve, but had way more left over. But then if you did 4 rectangles instead, well, they became thinner, and you were able to make a more respective approximation of the area under that curve. Still, we didn't account for all of it because the rectangle won't touch everything in a curve. Then if you were to, like, let's say, I don't know, multiply the number of rectangles by 10, that started to provide like way more insight to what the area under the curves would be. Basically, in a nutshell, the more rectangles, the better for our approximations. That's why the whole dx ideology comes in with the integration of the antiderivative. That's going to represent your thickness of the rectangles. The more rectangles you use, the better. But then it became an issue of deciding whether or not, with the whole rectangle areas. Well, for example, if we had to find like technically an area of this one, we're going to be applying just the power rule for the antiderivative, of course. We know it's going to be the backtrack of the power rule for derivatives. We know in derivatives, we took the exponent out front, subtracted 1. To move backwards, you're going to have to add 1 to the exponent and, well, divide by that. So if I have to find x cubed dx, the integration, that's just simply going to become 1/4 x to the 4th plus c. Again, we have to account for the constant of differentiation, or the constant of antidifferentiation, because that's a family of functions. All constants, when you derive them. The quickest way to check that you got the solution correct, just take a derivative of it, multiply the 4 out front. All we're left with is an x cubed. We did good here. The constant goes away. That's going to be probably the most concise format of making sure that we can identify how to tackle it. Because now when you're dealing with the rectangle approximations on the test, well, they're not ever impossible. We just have to make sure that we understand how to play the game. And so with the whole adding of the rectangles underneath, we do have to know how to apply that number of rectangles to it. It's always going to be part of the issue of like the actual definite integrals. We definitely just have to make sure that we're carefully labeling everything as we're figuring it out. Like, for example, this is going to be something where we have to try to use the table of values to deal with the, well, 6 subintervals indicated by the data in the table to approximate that. But now the big secret, Riemann sum, they have to tell you where to look at. Notice how they tell me 6 subintervals, which totally checks out. 1, 2, 3, 4, 5, 6. When we do get to that, if we're dealing with the right-hand sum, I'm gonna be just taking a look at the values that I arrive at with the with the right-hand Riemann sum. I don't know why I can't talk today. I'm so sorry. You're basically taking your rectangles. If you're looking at the left hand, you would be starting at the left-hand side. We have to start here, which means we are going to be using boom, 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 boom. But now, since they give us the whole values in there, all we have to do is go ahead and use the values in the g of x and then combine them. With the Riemann sums, don't ever overdo it. I'm going to show a visual representation of this quickly, but it's just a matter of knowing what part you have to focus on. So let me get one of those up here. Then also, like, rather than just doing the whole rectangle with the left hand or the right hand, you then had like a midpoint, and then you were able to find potentially trapezoidal. Like, so for example, this is going to be the visual representation of it. Notice that's our information. That's the area that we have to identify from 1 to 3. Back in the day, people just started putting the rectangles, like I said, but look at all the leftover space. I don't know that. I don't know that. It's definitely an underrepresentation. That's why they started adding more rectangles by like lessening the thickness. The more they added, the better once they got to. But with the left-hand point approximation, that was directly underestimated. Look at the right endpoints. It definitely encounters everything with the shaded region under the graph, but it's still not an exact, it's an over approximation of it. But again, with this, if we do use, these are going to be the values that you would arrive at. So then people started thinking, okay, if the left was under, the right was over, let's take the average. Knowing any 2 points, you can always identify the average, or we know better as the midpoint. And so when you're dealing with the thickness of rectangles, you're just going to start the values of the b minus the a, or the closed interval, divided by the number that you want to figure out. That will be the width of each rectangle. Since we know the area formula for rectangle is length times width, that's going to be what's on the outside of your parentheses that you'd have to distribute to every term, which is what we have here. Notice with the left endpoint, you're starting with the initial y value, the initial output, and you're not going to the end. No, you're ending with the second to last one because that's the farthest left endpoint that you get. The right endpoint, it's just going to invert the ideology for the beginning and the ending terms. And so instead of like the y naught or the y sub 0, that one should be y sub 1. And then over here, you're not going to have like the y sub n minus 1. You're going to have the y sub n because you're dealing with the right endpoints. So here, you're not going to, like if it were the table of values, would not start with the leftmost. You would have to start with the second from the left and then continue to the end of the table. So now with this, here again, the 4 rectangles, but now check out what the midpoint did. It absolutely tried to balance out what was not accounted for with what was accounted for. And check it, this unshaded rectangle or triangle, it absolutely looks like that's the perfect fit. Here's when they started to realize back in the day they were onto something. It was a net change issue. It was just kind of basically trying to get it to balance out to the 0. Again, it looks like they're just basically cut and paste. With that, the midpoint formula definitely gets you the most most precise expression for the area before like the integration curve, of course, the Leibniz notation. Now with the general formula for the area over curve with the midpoint, here you'll notice yet again the thickness, but now with whichever intervals you're at, like from 0 to 1, well, that would be the midpoint 1/2. From 1 to 2, the midpoint would be the 3/2, so on and so forth. That's why they're accounting for this. You're not dealing with the actual x and y coordinates, you have to find the middle. But then want to take a look at the trapezoidal property, because that was probably going to be the trickiest one. I'm not saying that's the one that they would throw on the test. I'm just saying it's a possibility. But the trapezoidal is totally going to make us be able to identify and set up more representative area approximation if we had to, because your trapezoids, you know, they have the slanted sides. They finally figured it out. But again, you're combining straight lines on curves. Those two do not mesh at all. With that, well, do you have to recall your area formula for the trapezoid? So what we're going to be doing here, well, we're still going to have to know the thickness of the rectangle or the trapezoid, because that's going to be your height and what you're going to be multiplying out front with it. Then you're going to deal with your b minus a over n. We have to talk about the magic that happens on the inside here. With that said, this is why it was the trickiest one, because of what you had to be prepared to remember. We know, again, all we're doing is recreating the trapezoid area formula that we know from geometry. Here, the 1/2 comes out front, absolutely. There's nothing new here. That's your thickness of the rectangle. It's going to let you know how many you're going to have to create. And then look at the first and last term. Notice it's not anything like the y naught and then the y sub n minus 1 like we have with the left and right endpoints. That does not come into play. You're going to start and end on the entire interval. But look at the magic in the middle. However many you're going to have, you're doubling all of them. I can't just take the 2 out front because, again, I'm not doing that to the first and the last term, but I have to double everything there. It's going to be what we're able to do to get our closest area approximation. With the whole area under curve, though, you don't have to go much farther than that, quite honestly, because Unit 8 is going to deal with the applications of integration. Area under curves, using the definite integral notation, volume, cylindrical shells, slicer, washers, disks. It's going to be just knowing this would be at the most so they can ask you regarding the area foundation of calculus. But that's not where you stopped. When you started to get into further into calculus, you had to identify and be prepared to utilize antiderivatives of a variety of functions. With this, that's where we had to find out the difference between the chain rule and use substitution. Chain rule, we knew, took derivatives and went in one direction. We just had to start with the outside, work our way inward. The chain rule, we have to be able to identify what we could do in its inverse with the integration. That's why use substitution exists. When I plug in for use substitution, I'm simply trying to plug in what I have a derivative for in this actual integrand. For example, if, let's see what we got here. Question. Would finding the area in between multiple curves be an application? Great question. That is explicitly stated in Unit 8 for AP Calculus AB. So for this test, you're not required to know it, but if you are extending into BC, or if you're going to be taking like the next sequence, you'll have to know it going into there. This is not going to like pick up in the end of AB. And how will Unit 6 be tested on for a question if there's no integral applications? Oh, use substitution or Riemann subs. The examples I was showing here, those are going to be probably the most common ways that they're going to be bringing it into the test, if I had to guess. But yeah, the unit or the use substitution would probably be the heavy hitting application. For example, like here, not only do we have to use substitution, we have to be able to recall our trigonometric antiderivatives. Remember what I said in the second live stream, When you're taking a derivative of any trig function with a co, that derivative has to be negative. If I'm taking the antiderivative, thankfully, I know it's not going to have like any sign change, but it's a wrench in the plan because I don't just have an x in here. This would probably be the most heavy hitting of the integration concepts they could bring your way on the test. The 3x is the problem, which means I'm going to let u equal 3x. The only reason I'm choosing that, because when I take the derivative, I'm going to have it in my integrand. Notice I don't have a stray x anywhere else. I have my differential right here. So if I take the derivative, power rule to the rescue. But now notice again, I don't have a 3 like outside of the trig expression. Like I don't have 3 secant squared 3x dx. If that were the case, I wouldn't have to do anything more. Like I know my u, I know my du, and I could just plug and play. I only have a dx though. I have to get the dx by itself. Only way to do that, I have to separate it. Now notice, I have the internal function for the trig. I have my differential. Everything that's accounted for, I am now all systems go to apply the integral. And so, secant squared, that's going to be my u. The dx is equal to the 1/3 du. Since 1/3 is the constant, I bring that out front immediately. And then everything's accounted for in a single variable. The u substitution when you first start out, it is like tedious plug and play when it comes down to it. With the whole u substitution ideology, you just kind of want to go and let the u equal, for the most part, usually one of the higher degrees in the entire integrand. But as far as working backwards, well, in the other video as well, I said for the whole tangent secant, for the cosecant cotangent, remember 2 and 1. I have 2 secants, I have to have 1 tangent. Yay. I know I'm gonna have to include the constant of integration since I don't have a definite integral, which would probably be, Mohammed, the other way that they're gonna incorporate the integral applications, putting it on definite integrals and then letting you plug in and evaluate, do the fundamental theorem of calculus. And now the final step. Just have to resubstitute back. Game, set, match. Definitely one of the friendlier ones, for real. It still looks ugly because, I mean, I like don't ever understand like how they're dealing with some of these, and they look so ugly, but they work out very nicely. That's the common good feeling to look out for on the test. I'm not saying that it's not going to take a couple steps to get comfortable with or to like kind of get it correct. Just have to be prepared to look for ways to get everything down on the paper. Like again, here, I only have the one trig function, so there's no possible way I can let u equal cosine, simply because, well, I don't have a sign anywhere in that derivative or in that integral. I wouldn't be able to identify a du. But now I look on the inside. Oh, sorry, there's a spacing issue here. It looks like the pi times x. Yet again, that I do have a derivative for because I have the differential dx right there. Let u equal pi times x. You may be already identifying this is going to work out the exact same way that the previous one did with our differential for du. The x is going to go away. Beautiful power rule to the rescue. I'll be left with the pi dx. But again, I don't have like a stray pi out in front of everything. No. I have to get the pi to the other side. And here's where it becomes exactly the last question we did. There's nothing new when it comes to u substitution. They can only just pick and choose varying difficulty ones. If you do have the AP cracking the AP Calculus AB exam book, we have a lot of practice questions you can take a look at regarding these so that you can home in on your u substitution. I know then, since this is, again, only the 2 possible questions in the free response, this, if they were going to bring an integral, I'd have to imagine that this would be one of the bigger things that would be involved with the integration. but then I just have to know the trig antiderivative. Again, I'm taking an integral of cosine. That's not going to change the sign because you had to take the derivative of the sine to get the cosine. Now, so technical rewrite. 1 over pi, the integral of cosine of u du. Everything checks out. When I go ahead and take the antiderivative, I'm going to have the 1 over pi sine of u. And again, my constant of integration. And then I'm just going to rewrite in terms of the original expression. 1 over pi sine pi x plus c. Like, more than likely, your math teacher said something in class when you're encountering the whole u substitution, maybe on like the same way that my teacher introduced it. U substitution, this one's the trickiest because you kind of, when you're starting out, just have to guess and check, see if it accounts for it in everything they give to you. With the U substitution, there really is a method of the madness. But like when you have only one trig function, you know when you take a derivative of a trig function, you're going to have another trig function. If you have two trig functions in your integrand, for the most part, you're usually gonna be letting one of them equal u. If here I just had the cosine, I did not have a sine anywhere. I had no choice. I could only plug in for the pi x, and there's the derivative. And so we just have to kind of look for the original and then the derivative. By the way, will the motions questions that require integration be tested? For that one, I would have to say that would still fall under the applications of integration. Now, I did not check the entire scope for the Unit 8 before the session today. So at apcoronavirusupdates.org, you're going to be able to access everything for the AP Calculus. On BC, yes, that's going to be there. For AB, I want to say, if I had to go with my gut feeling right now, I would have to say no, because it is an application of integrating. Will extended time still apply on the online exam? Here, if they did approve you for extended time, they will absolutely let you know specifically. With the whole doing extended time, you're going to get an email 2 days before, like your exam date, with your actual like login ID for your AP exam, and they're going to let you know every detail about the whole extended time, whether it's been forwarded to you. In the YouTube video that we had showed up in the chat window a little bit ago, from moderator put it in there. If you click on that video, they're definitely going to only quickly discuss the whole extended time, but yeah, they're going to let you, they will let you know. As long as you're awarded it, they're going to let you know. It's possible there would be a curve sketching problem. That was actually going to be what I was going to plan to close out with this one, because it shows everything. But yet that would be more than likely one of the core concepts to expect with the whole ideology of sketching the curve. We just have to make sure that we're remembering how to react. Again, we're going to get to the point where it's going to be the whole take a derivative set equal to 0. The curve sketching is pretty much what they're forcing us into when we can't use our graphing calculator. We just use the calculus to determine everything about it. And that's where you're just going to have your checklist that you have to get through. For example, sketch the equation of that. So now with this one, with curve sketching, the only potential hesitation I would have in it, you might not have to draw the graph. Definitely not for like submitting it on like the copy paste. If you do have to draw the graph, I might recommend by hand would probably be the easiest way to upload the solution in terms of making the safest use of your time. But now here, don't forget the like kind of things that you have to consider. I was always taught them as dias. Yes, Spanish days. D, find your domain. Here, everywhere. There's no hiccup whatsoever. So all x such that x is contained in a set of all rails. Second, intercepts. What happens with that? The intercepts, you just have to set any function, any polynomial equal to 0. You can look for ways to factor and then identify what the zeros are. And so here we would absolutely do that, and we could identify. I would take out the x, or I'll factor it out, because x equals 0 is totally going to be one of your intercepts. And then x squared minus 12, just add the 12 over, plus or minus square root of 12. So x equals 0. And ba-bam. The A, any asymptotes. The trickiest part here, anytime you have a rational expression, you know automatically you're usually looking at vertical asymptotes. But now be careful, if your denominator is like x squared plus 1, you're not going to have an asymptote there, because everything's going to always be positive. Like, you can never have it equal to 0. Here, I don't really have any vertical asymptotes at all. There's no place the expression does not exist. And then any horizontal asymptotes, not really. It's going to be traveling without bound. It's a cubic expression. I'm not going to have any roadblocks along the way. The symmetry, though, this can help you, just like when you're trying to put the figure together. If you can identify it as even or odd symmetry, that'll let you know the rotation. If integrals of function was in a free response question, what would it look like? That could easily be about the Riemann sum or the left endpoint, right endpoint. So they could actually like give you a function in an integral notation, or they would provide you like the box of values. The one that I had up there for the whole Riemann sum a little bit ago, when we just had like the 6 columns of numbers in the table. If I had to guess, for a convenience of showing it to us, that would be what I would expect them to put on there. They can do anything, though. They can totally give you the function and make you determine the areas of the rectangle, or the thickness of the rectangles, with the b minus a over n. Just have to be careful that you're reading everything that they're giving to you. So it's really up to them in that regard, but I would have to say anything dealing with any of the areas dealing with right endpoint, left point, midpoint, or trapezoid. Again, I don't know like the absolute 100% answer to that, unfortunately. I just hope that provides some insight to at least let you know like what to kind of take a look at throughout the rest of the week. So we've now like exhausted everything with the pre-calculus stuff. Now I have to go into calculus. My function, the x cubed minus 12x, first derivative to the rescue. I'm going to change the color just so we know that. Power will to the rescue. I'm at the point where I take the derivative set equal to 0. I'm now going to identify my critical points. Add the 12 over. Divide by 3. Plus and minus square root. What about the fundamental theory of calculus, how it'll be tested, when to use it? For that one, if it does show up, it's simply going to be not like a crazy chaotic one. For fundamental theorem of calculus part 1, that'll be just a differential integrate, or definite integration. When you have the integral from a to b of your function, you just have to take the antiderivative, then plug in your b value first, subtract your a value from that. The second one, that's going to be whenever you have like the f of t function. The most common notation is going to be from the 0 to the x, ft dt, like that. We know when we take the antiderivative in the friendliest format, you just have to basically take the antiderivative and then plug in the x. If you have anything different than an x up here, you're going to have to account for the chain rule antidifferentiation and multiply by the derivative of whatever that is. That's probably as quick as I can answer, because I know I'm running low on time right now. But now, when you take your first derivative, you have to find your critical points. The second derivative would just be doing the same thing to find your points of inflection. You just have to check the concavity. Dear Lord, these are always the fastest hours. Oh, please, if you didn't have like a chance to have your questions answered, keep an eye out for like when the video posts for this. Fire off questions in the chat, in like the bottom group chats, for real. Definitely take a look at the earlier videos, any comments that were added. I try to keep an active eye as possible on those and try to reply as quickly as I possibly can. I'm usually checking the YouTube videos like at least once or twice a day at the very least. If you didn't get like a question answered directly, please do sound off on the comments when the video posts online. I will absolutely do my best to be a benefit for this and the test. You know what I got to end with though, for real. Boom. Again, fastest hour ever. Just remember to breathe. Do a little bit each day for every hour. You know my rule. Don't forget to take a break. Don't ever skip breaks. You've earned them. Make sure that you're setting up your scratch paper. I know we're over time. I do have to be closing down the transmission, but I just want to say thank you all for hanging out. Like none of this is ever possible without any of you. Breathe. Come up with a game plan. Get everything out of your head, one thing at a time. You're gonna get through it. It's way worse in our minds than it's gonna be. Remind yourself of that. Again, thank you all so much. Have a wonderful day. Happy prepping. Post some comments and I'll keep an eye out for your questions. Thank you, everyone. Kick some calculus butt.